whether a force is conservative or not. Force is conservative or not. Okay, so how to know whether a force is conservative or not? So first, to know this, first what we have to do is the most basic method. We will go by definition. We have to check the work done through different paths. Okay, so we have to check the work done through different paths, and there are some rules also. So if a force is constant, the force is always conservative. Okay, if force is constant, if force is constant, then it's conservative. Okay, then I cap has only function of x, and j cap has function of y, and k cap has function of z only, then that is also conservative. Second, I am writing the I cap is function of, suppose, x only, j cap is function of, suppose, y only, and k cap is function of z only, then this is also conservative. Okay, so what does it mean? It means that if you have x I cap, suppose y square j cap, if you have z k cap or z by 2 k cap like this, so this will be conservative. Example, because I cap component is only function of x, j cap component is only function of y, k cap component is only function of z, so this is conservative. Okay, so these two are basic things which you can find. Otherwise you have to check for different paths, and if you are not able to decide by these two rules, then you have to check from different paths. Third thing you can do is check work done by different paths. Okay, so this is the final thing which you can do. One more method is there, that is the higher method. So for that you need to know some higher mathematics, so that I will discuss at the end of chapter. Okay, so just remind me after, when the whole chapter is finished. Okay, so we will discuss. So fourth one is the curl method. So that we will discuss at the end of chapter. So now I will give example of the work done calculated with different paths. So how can we know that whether a force is conservative or not? We will try to find it while calculating the work done through different paths. So take an example for this one. Okay, so take an example. So suppose we have a force So take example. So suppose we have a force like this, F equal to y I cap and x j cap. Okay, force is like this. So we have to find it's whether it is conservative or not. Okay, so find whether it is conservative or not. Find whether it is conservative or not. Okay, so how do you find it? So we can take a path, we can choose two different paths and we can calculate the work done. Okay, so let us choose two different paths. Suppose particle is starting from point 0, 0 and going to, suppose 1, comma 0, and then going to point 1 comma 1. Okay, so these are the paths. So from A to B to C, this is one path, and another path we are going to take, suppose this one, A to or we can take like this. Another path we will take direct. Okay, directly A to C. So we will calculate work done from path A to B plus B to C. Okay, so we will see how much is the work done. So first we will calculate A to B. What will be work from A to B? So in this case, the displacement is along x direction and the force is how much? Y I cap. We will write the force into displacement. So F dot dx only. Dx I cap. Why dx only? Because from A to B, the displacement is along x direction. So F is y I cap plus x j cap dot dx I cap. So if you integrate it, you will get, see, the j cap part will vanish, only I cap. So y dx you are going to get. Okay. So what is value of y during this path? So at this path, you can see value of y here is 0. Value of y at AB is 0. So you are going to get 0 dx. So value of y is 0 at line AB. Y is 0 at AB. Okay, that's why we are getting 0. Now we will calculate for path BC. For path BC, again we will write same thing, F dot, but this time the displacement is along y direction. So if it is along y direction, we will write it as dy j cap. Okay, so if you write dy j cap, it will be how much? The force is y I cap plus x j cap and dy j cap. Okay, so how much we are getting? So if we solve it, so I cap part will vanish, only j cap part, so x dy. Okay. And how much is value of x? So at this point you can see the value of x is 1. Here the x is 1 because this line is at a distance 1 from the y-axis. Okay, so value of x at this line CB is 1. So, and that is constant, x is constant throughout. So 1 into dy, and dy is varying, the y is varying from 0 to 1. The y is changing from 0 to 1. Here y is 0 and here y is 1. Okay, so 0 to 1. So we will get 1. So this is the work done. So total work done for path